All right, hello and welcome back for another math lesson. What we're going to start doing today, but not finish, just start doing is possibly the most important and potentially most confusing things that we'll do in fourth grade math. I really wish I could do it with you in person, but at least you can watch the video a couple different times if you want a little bit more of an explanation. Again, we are just starting it now. I'm not expecting you to finish your learning with it right now. Okay, so quick, just to review. An array is related to area because when we think about an array is the amount of space in the middle of the area. You know, we were in the rug in the classroom, I would say, no, so in the area of the rug, you sat in the little squares in the area. So the area is the amount of space inside a shape. What we're doing now is almost always going to be rectangles. So what we're going to be thinking about is instead of drawing it out, because we're using bigger numbers now we're going to be thinking about the area as just a number. It's like 98, for example. So that means that if I was to draw an array in there, I could do that. I would just have to draw 98 X's or boxes or dots or whatever. So what we're going to do is to try to use some drawing to help us to figure out how to take some shortcuts to that to be a little more efficient. Something I haven't mentioned that hasn't really come up recently is that, okay, when you're adding, when you're doing addition, the answer is called the sum. When you're subtracting, the answer is called the difference. When you're multiplying, it's called the product. And in division, the answer is called the quotient. So the answer in a division problem is called the quotient. What we're going to do is to find the quotient, find the answer, but we're going to do it by taking parts of it. So we're going to be finding the partial quotient. We're going to find the quotient by getting there in parts. All right, so with that, let's go to the lesson, the problem. We only have one problem that we're working on today, so I'm going to try to do it as clearly as I can. You know what I'm going to ask you first is, what do you know? The fifth graders are making a rectangular mural for the gym wall. They have 98 square foot tiles. If the club members want the mural to be 7 feet long, how tall will it be? Okay, so I just had a picture of a mural. This actually doesn't really match the problem that we're doing, but it's the idea of like making a really big painting made of smaller pieces here. Okay, so what do we know? We know fifth graders, okay, that's good for them, not important for the problem. We know 98 square foot tiles. And we know that they want the mural to be 7 feet long. Okay. What do we know? What does 98 square foot tiles mean? 98 square foot tiles means that the space in here, the area or the array, is going to be 98 tiles or 98 squares or 98 X's or 98, just anything that you want to think of it as. But this whole space in the middle is going to be 98. And that did not come out very well, so I will give it a little background. Okay, 98 squares for this whole mural. And we know that one part of the mural is going to be, and you know it, this is going to be way too big, is going to be 7 feet long. Okay, so that's what we know. We know that this is going to be 7 feet long. We know that this inside is going to be 98 squares. What we need to figure out is, how tall will it be? Now, I know I'm really tiny in the corner of your screen, but when we're talking area, we talk length times width. So we need to find out how wide or how tall it is. Okay, so the cool thing about partial products, other than it's probably different than the way the adults at home learn how to do division, is that there are lots of ways to get to the right answer. Here's what I mean by that. So we know that this is going to be 7 feet wide. So from here to here is going to be 7 feet. 7 feet. I have 3 of these because I thought we could do 3 different examples. Normally I would have you raise your hand and call on you, but hopefully you're asleep by now, by the time I'm making this video. Okay. So we need to find a way to figure out how can we make this part equal 98. We know that it's going to be 7 feet times some number, some width. Okay, so how can we split that up? All right, so let's think. We could, let me try white again. We know this is 98, but we can break 98 apart. So one thing that I like to do is to figure out some with zeros, with tens. So if this 98, if I were to think of this whole rectangle here and just take part of the 98, I know that if this is 7 and I wanted to make this part in the middle 70, seven times what would give me 70? Right, 10. So that means from here to here, lots of switches here, so it's so much easier on a board. From here to here is 10 feet. Okay, that got us to 70 square feet. But we need 98. So how much would be left? If we had 98 and we figured out 70 of them, then we would have 28 of them left. So let me just show what I mean by that. We have 98 square feet total. This is the area. This is the number of X's in the array. We figured out this here would be 70 squares here. And then we need to get to 98. So 70, 80, 90, 8. Okay, so I'm not sure. Let's just say I'm not sure. 7. So now we need to figure out another multiplication. We need to figure out how much this is. So we did the green. Now we need to figure out what the yellow is, and we can add these up together to find out the total length. But let's say I don't know that 7 times something is 28. Let's say I don't know that problem right now. I'm just like it's late. I don't know what really that could be. I can take those 28 square feet and I can split them up again. So what I can do now is I can take the 28, this whole thing is 28, I'm going to take just half of that. What would half of 28 be? 14. And since I did half, then I can do 2 of them to get the 28. All right, so now, what's happening? So now I have my 70 square feet, I have 14 square feet, and I have 14 square feet. I know that that's going to equal the 98 square feet I need, but I haven't figured out yet what the height is or what the width is. So I had it in yellow before, but now I'm going to use orange because this is still 7 feet this way. 7 times what would give me 14 square feet? So I would have, this would be 2 square feet to get this. And because I did that once, I can do it again to get this last little bit in yellow. So it was asking me, how tall will the mural be? The height is going to be 10 plus 2 plus 2. 10, 11, 12, 13, 14 feet high. So this problem is going to be 14 feet. I'm going to put this over here because I don't want you to think it's this 14. Okay. So that's one way to solve it. Another way you could solve it, and really there are countless ways that you could solve this problem. Let's say you felt a little stronger in your multiplication, but you still like your tens like me. I'm still going to think of this 7 feet. Since it's 7, I'm going to want to think, can I do it times 10? I can do it times 10, so I'm still going to call this 70 square feet. So that means that this first height is still 10 feet. But now, I still know that this second part is 28 feet. So I guess I'll just go yellow again. Remember, I got the 28 because it was 70, and I need to get to 98. 70, 80, 98. Now, let's say you know your 7s or your 4s pretty well. So then you might know that this is just 7 feet wide and 4 feet high will give you an area of 28 square feet. If I do 10 plus 4, that's going to get me 14 feet tall. Let's say 7s are not my favorite. 7s are kind of hard. They take me some time to remember. What I could do is I could totally break this down. 7 feet one time would be how many feet? That would give me 7 feet. And I'll fix that font, just give me a moment. Okay, super teeny tiny, but 7 square feet, and that is 1 foot tall. 7 times 1 is going to be 7 squares. X, 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 7 squares. So that was just 7. So now what I can do is I can think, okay, 7, here's another 7, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 21, 28, 35. So you see what I end up doing is I'm just doing repeated addition or skip counting like we talked about last time. Be so precise with this and it's still not really gonna match. So I can just think of this as doing a bunch of just rows of 7. Here's my 21, 28, 35, and I could keep going until I get up to 98. So spoiler alert, how many times do you think I will have to do 7 to get up to 98? I will have to do it 14 times. All right, so partial quotient. We've talked about an array. We've talked about an area. Division is taking an area and then trying to find out what one of the sides is. Instead of trying to find the whole side at a time, because we're using bigger numbers, we're going to be finding part of the side at a time. So what you're doing is you're finding part of the answer at a time. You're finding part of the quotient. That's why this is called partial quotients. So that was a lot. I'm not expecting you to master this right now. I'm just expecting you to try. What I'm expecting you to do is when you're taking this and working like on your own, maybe on some paper or something you can write on, I'm expecting you to draw a rectangle like this and to have to start to divide it up. 7, I know 70 would be quick, so that would be 10. And then I said I had 28 here, and that was 4. 10 plus 4 is 14 feet wide or tall. I'm expecting you to be drawing some of that stuff out. Drawing it will really help you to find the solution. If you're not sure if your answer is right, you can always do another box, another rectangle, another area, and try to do it a different way. Maybe you want to divide it up into 14s. This is still 7 feet long. You can do your 14s. And the nice thing about doing this on paper is that if you need to make your box bigger, you can make your box bigger. So yes, draw. I'm asking you to try drawing because it can help you to get this, and any guess that you take, you can use what you get from that, even if it's 14s. So give these a try. You'll need to do some drawing, and I'm going to ask you to explain your drawing. If you want to, you could even take a picture of it and I put that into the slideshow that you're working on. This is big, this is challenging. It's okay to get frustrated. We are not done learning this. We will keep working on it. I promise you, you will understand this. All right, be kind to yourself, and I'll see you at 1 o'clock. Bye.